Thank you to all of you for being here as well. What a phenomenal energy outside and inside the room, right? I think we are still trying to forget the traffic woes of Bangalore, looks like, right? The long walk across the bridge from the flyover. If some of you come from the Eco World side of the Bangalore city, I see some familiar faces also in the crowd, so thank you for being here. Wonderful. So I was looking at the topic list for the DES Summit, and it looks like there are more GenAI sessions than data engineering sessions. That's the state of affairs today, right? Because all of us want to learn more about that. But the thing is, they're definitely not two different things. The GenAI sessions are very closely related to data engineering, because without a very solid data engineering foundations, you cannot have a very good GenAI, right? Goes without saying. So great pleasure to be here, and the first speaker of the summit. It wasn't intended to be, but it happened to be the first session of the day. So again, a big thank you for being here. All right, so we all hearing about GenAI. We're kind of getting drowned into GenAI and all of that. What we are seeing is this is the year when we will see more and more use cases going into the production. Because last couple of years, we saw a lot of experimentation, pilots, different types of hosted models, API models, and all of that. And now it seems like we have come to a place where more and more of these use cases will go into production. Yeah? I think we will also get questioned on the ROI. What is it really that we are getting out of these projects? Are we really seeing value in it? So for both of these things, one is to roll these projects out into the production, and other is to derive the ROI out of them. The big thing is how solid is our underlying data engineering foundation. Because for the enterprise AI, if the data is not good, if the data is not high quality, if the reliability of the pipes which are feeding the data is not great, these GenAI products cannot be productionized, right? So that is the fundamental and most important aspect of building these into the production. Now, that is definitely one big disruption which happened in the industry, right? A couple of years ago, the big thing about GenAI and now rolling it out to production. The other big thing we are seeing from a disruption standpoint is this data interoperability. These ability to have multiple engines talk to the same data, regardless of which engine originated from and so on. Now, of course, open table formats are not new. They have been there for a while. But what has really happened is the vendor support, which has built around formats like Iceberg, has become phenomenal, right? For a long time, the open table formats were kind of very closely guarded secret with certain vendors, only one vendor supporting one particular table format, and then the other one was sort of, dying off. But then we had Iceberg, which suddenly popped up on the screen, and huge amount of support from a large number of vendors over there. So that has kind of changed the equation now. Huge adoption from Iceberg side. Number of vendors which support that ecosystem is big, and the contributions are coming from all sides of the equation. It's not just one vendor, but different customers, vendors, partners supporting the Iceberg phenomena. The other thing we also saw is on the catalog space. The catalog has also been sort of a problematic area, because initially we had a high meta store and so on, which didn't really caught the fancy because complex, not very scalable. And then again, we had proprietary catalogs. What really is happening now in the Iceberg space is that catalogs are also becoming open source, so that you are not dependent on a particular vendor, but regardless of the vendor, you can actually make use of the same catalog. If you really look at this phenomena of table formats and catalogs, it's really an unbundling phenomena, right? We all have some database background. What the databases were doing in a single engine, single place, the open formats have kind of unbundled that, right? So we took the storage, put it into a different system in file formats. We took the engine and we said, OK, multiple engines can work. Then we look at the governance and the controls and permissions and said, OK, we now have a catalog, which is again unbundled. So this whole thing got unbundled. And now they're coming together again in a fashion which is completely open and can be used with multiple interoperable engines, right? So that's what's happening in the catalog and open table space, allowing multiple engines to talk to the same data and maintaining the same level of governance. Now, on the GenAI side, if you really see, one big thing it is doing is just what SQL did to structured data. LLMs are doing the same thing to the unstructured data, right? SQL made it really easy to get value from tables, rows, and columns. LLMs are making it very easy to get value from PDFs, audio, video, all sorts of multimodal data, right? We all used to say that 80% of the data in the world is unstructured, right? The problem was that unstructured data was lying there in storage systems, in deep cold storages, but there was nothing happening on that unstructured data. Or even if you wanted to do something, it was really, really hard. The OCR technology, the NLP technology was a domain of very select few people, and it was really hard to get value out of it. What GenAI has really done is put the button in the hands of everyone, that regardless of what you do, you can actually get value out of unstructured data. This used to be a domain purely of data scientists, people who could deal with libraries like NLTK, Spacey, all of these, right? And then get into natural language and get value out of it. What LLMs have done is now data engineers are empowered to just look at unstructured data as if it is, again, a source of structured data, get it into our data system, combine it with the rest of the data. So it is leading to a very tight coupling between the structured and unstructured data, which was very, very difficult earlier. Yeah? With these two disruptions, what we are seeing is how the new age or how the modern data engineering stack has been built is few principles around these, right? As I said, more and more you want to put things into production, you need to have more robust and reliable pipelines. The first principle there is, how do you simplify this architecture for the AI? Because if something is very complex, it cannot become mainstream. It cannot be widely adopted, right? So to make this AI products really mainstream, we have to simplify the underlying architecture and the pipelines and the data engineering required for that. So first thing we are seeing is companies will want to go in a direction which helps them simplify this entire architecture for AI products, right? Right from the time data is in the source, bringing it into places where it gets consumed, and that entire life cycle of AI coming together on the data, it needs to be simplified. So that is a big area of focus and emphasis which we are going to see from a data engineering side. You all must have heard about RAG pipelines, and now we talk about MCP and A2A and all these agentic frameworks, right? So things will have to be brought in a way which makes it very easy to bring all this together in a simplified manner, right? The second thing, like I said, is open and future-proof platforms. People will not want to invest in things which become sort of closed or cannot be built upon with multiple layers on top, right? So more open table formats, future-proofing with different production engines built on top. So that's more on the simplified and openness of the side. If you see the second pillar, it's more around the productivity and integration with DevOps practices and zero operations. You know which are the best data pipelines? Which are the best data pipelines in the world? The pipelines which don't exist. The pipelines which don't exist are the best data pipelines in the world. Because let's be clear, if pipelines exist, they break. And when they break, all sort of health get loose, right? So how do we make the zero operations data pipelines, reduce the amount of friction between the data and the products, build as less pipelines as possible, and whenever we have to build them in a very robust way, build them in a way where developers can really control them with enough amount of observability and integration with their day-to-day practices. So that's more around the developer productivity and making as less operational overhead as possible for the developers. On the third pillar, if you see, it's more around governance and efficiency, because when you want to put things into production, you want to make it very well governed, very robust, tightly controlled. Even when the LLM models are built, the biggest question is, how do you make sure that the output of these models are not available to people who do not have access to this data? When we implement RBAC on the data systems, it is very easy. There is an RBAC, there is a person who has access to it, there is a person who do not have access to that. But when you build LLMs and you open it up to the entire enterprise, the questions you ask, how do you control what answers the LLM gives to which person? It's very hard to control, right? Because it's a chatbot we have built and anybody can ask any question. How do you tie this RBAC controls right to the application layer so that the answers which you get are controlled at the access layer, right? These are some of the challenges we will see on the governance side. Ultimately, we all want ROI. Our CFOs want ROI. So how quickly, how fast, and how in an expensive way we can deliver value, that will continue to be a big driver with data engineering practice as well, right? So 3 big pillars. Number 1, simplification and openness. Number 2, productivity. And number 3, governance and efficiency. These are some of the big principles we are seeing from a data engineering practice standpoint. Now let's see how we can look at some of these principles and how Snowflake really helps there. So first, when we talked about unstructured data, the biggest thing with unstructured data is, number one, it's lying scattered in multiple places. So our object stores, or maybe even on-prem places, it is tied into the application, so on and so forth. How do we take this unstructured data and get the important values out of it, right? This could be invoices, contracts, loan documents, so on and so forth, right? There are fields of importance which you want to pick up from here and then bring it to people who are on the field so that they can operationalize all of this into their day-to-day life, right? There are doctors' prescriptions, MRs which go on the field, and all of those handwritten notes also need to be brought into that. So now with LLMs, what's happening is you have LLMs which are really good in reading this data, whether it is images, whether it is text, whether it is layouts, tables. These LLMs can really read all this data, and you can embed this into data pipelines. So for example, Snowflake has this product called Document AI. What Document AI does is it has a built-in model under the hood, really good in extracting certain specific fields from these documents. So if you have these invoices or contract documents and have certain fields of importance, you can extract that and bring it into the tables very easily. You have a UI where you can define some of these parameters, and it builds the pipeline automatically. It gives you a function. You just invoke the function, and basically the data keeps coming into your tables from the unstructured data. Now, of course, there are multiple options here. So Document AI, there is also things like parsing the text based on the level of resolution of the image or the complexity of the document. There is also multi-model LLMs now. So if you want to do charts, for example, charts cannot be parsed in a normal way, right? So if you have charts and want to correlate with that certain things in the document, there are multi-model LLMs to do that. So that's for simplifying the data engineering for unstructured data. Now, we also want to build search engines and chatbots on top of unstructured data. That's where we do RAG pipelines, right? Now, these RAG pipelines, typically, the way it is built is you have a place where data is being stored. Then you have a place where the AI models are running, right? So there is a lot of interaction between them. Data is coming into the data side, going to the AI systems, which are sort of embedding, chunking, doing all this work, and then writing it back to the data system. So you have specialized vector databases for this particular work, right? So there are vector DBs, there are unstructured stores, and there is then data warehouse or data lake. So again, multiple layers, which make it really complex. Now, what you can really do with Snowflake is you have something very simple called as Cortex Search. You go and build this Cortex Search service. What it does is, in the back end, it does all of this work for you. Embedding, chunking, building the index, all of this gets taken care of automatically. There is some bit of pre-processing which you need to do with parse text, but then beyond that, everything gets embedded with Cortex Search. And then on top of that, you can build a front-end UI with Streamlit, and then you can do whatever interactions you want to do via the UI with end users. Right? So easy to build these kind of RAG pipelines and make these answers very grounded in truth. Because in enterprise AI, you want enterprise data to be sourced for giving these answers appropriately. Right? So simplifying this entire RAG pipeline structure, that's another thing you can do with Snowflake. Just a case study, there's a customer called Compare Club. They help people compare financial products like Policy Bazaar in India, right? So you have different companies offering loans, different companies offering mutual funds and so on. Which is the best one to go for? They help people compare that. They did analysis of their voice transcripts when customers call, what kind of help do they need, what kind of problems they are dealing with, and how do they improve this service and personalize this service, right? So they're able to support hundreds of sales agents by building this particular application with Snowflake. The other problem which happens with LLM is that if you are making an external API calls, these APIs have to be invoked, and then the throughput which you get is not massive, right? So you get limited by the kind of throughput you get between the data and AI. By hosting these LLMs right into the data platform, you get much better inferencing and a much higher throughput. So you can actually process a lot more data in a faster time frame. So that was the first thing I talked about. How do you simplify the AI pipelines? Just a couple of examples, but there is a lot more you can do there. And that is going to be one of the principles which we see coming this year. On the open lakehouse side, if you see, Like I said, Iceberg has really become the de facto standard for broad vendor support. We see a lot more interoperable vendor neutral activities happening in that space, right? So we continue to improvise that ecosystem from our side, and it's of course open source community. So how do we bring things like variant data type there, geospatial data type there? So all the goodness which is happening on the Snowflake side, how do we bring on the Iceberg side as well? The next thing which happened is Apache Polaris, which is an open source catalog. So it's not tied to Snowflake. You can really use Apache Polaris in anywhere. You can host it in a container. You can host it in a VM. You can also host it in Snowflake if you want, right? So that makes the governance outside the Snowflake boundary. And you can talk to this catalog through multiple other engines. Could be Spark, could be any other engine for that matter. The third thing is in terms of the spectrum of workloads which can work on this, you're no longer limited to AI, ML, or analytics. You can bring new things like data sharing, data applications, and whether it's batch or streaming, all of that. So initially, the lakehouses were very limited to BI and AI type of work. What Snowflake started to do was bring this data sharing into the picture where regardless of which organization I'm in, we can start to do this collaboration across the organizations. Now that data sharing is also possible with open formats like Iceberg, right? And you can build data applications on top. So that's a modern open lakehouse. Again, a case study how Goldman Sachs built their lakehouse with Iceberg and Snowflake. They used to have this vendor onboarding process, different vendors who bring their data into the platform, and that used to take a long time because every vendor had a different way of bringing data through ETL pipelines and so on. So they really simplified these pipelines by using Iceberg and data sharing. So now all of their vendor data providers basically use Iceberg and then provide the data from there to their Snowflake account. And then within the Snowflake account, we have this lakehouse which takes the data in, builds the native applications, processes that through dynamic tables, and then leads to the final outcomes. Yeah? So 15x speed improvement in bringing data from vendors. Right, so that was on the simplification and openness pillar. Let's look at the second pillar of developer productivity. Like I said, the best pipelines are those which don't have to be built, but you still have to build some pipelines. Now, to that extent, what happens is we are also seeing a lot of movement towards what is called as declarative pipelines. So if you look at typically pipelines, we want to define a schedule at which this job has to execute. We also want to define what delta data has to be brought in, right? So there is a change data capture, things like streams, tasks, and so on. What Snowflake did was come up with something called as dynamic tables. It's a single statement, a declarative statement. You create this table, define with the duration, and that's it. Whatever SQL logic you write here, it keeps calculating automatically at a periodic interval on an incremental data set and keeps persisting those changes. So from a whatever line of code we had to write earlier in terms of scheduling, finding the change data, persisting it, it all becomes simple with a single declarative statement, and that keeps happening automatically, right? So again, big simplification from a pipeline standpoint there. If I want to eliminate the pipelines, then I have an option of data sharing, like we saw the example of vendor onboarding in that particular example. So now there are multiple applications which do this data sharing. So if you heard, Salesforce now has a data cloud, and there is a data sharing happening between Salesforce and Snowflake. So you don't have to build the pipeline. From Salesforce CDP, you can bring the data directly into Snowflake. Same way, ServiceNow has a connection with Snowflake now. So there are more native connections, more data sharing. There are multiple other app providers who are now doing data sharing so that you can eliminate those pipelines, right? So fewer pipelines with data sharing option over there. Snowflake also acquired this company called Datavolo a few months ago. This is now getting embedded into what we are calling Snowflake OpenFlow. And we will have more native connectors going forward so that you don't have to, again, bring a new ETL framework. But from the Snowflake account, you can configure a connection to the sources and then bring data inside. The third big thing we are seeing is how do we integrate more and more DevOps practices into the data operations. Right? The data code is becoming complex. It needs to be maintained and managed almost like we manage the software lifecycle, right? So all the DevOps practices in terms of continuous build, continuous deployment, continuous release, how do you integrate all those aspects with the data platform, right? So again, to that end, there are things like Python API, Snowflake CLI, declarative change management for the database, etc. You have all the integrations possible so that from GitHub, Git Actions, something like Bitbucket, you can push those changes of the code. First thing is you build the environment inside Snowflake through the, say, Python API. Once you have done that, you can trigger a code push into Snowflake through Snowflake CLI. So whenever there are changes, from the remote Git repository, we can push those changes. And then on an ongoing basis, continuous releasing these pipelines through integrations with Snowflake CLI. Right? We also made altering the objects very easily with things like execute immediate from or create or alter from the GitHub files. So you can easily integrate GitHub repo with Snowflake and push these changes into the system. Here is a case study of a company called Travel Pass. Basically, they manage the traveler's booking experience, the travel experience. So they migrated about a huge amount of data from Spark to Snowflake, about 130 dynamic tables which they have. They were able to go live in just about a week after migration. So again, big saving and very fast time to value. They saw 65% cost savings by moving from managed Spark to Snowflake. Now, if you are not familiar, Snowflake has something called as a Snowpark. What Snowpark does is whatever Spark code you have, you can bring that Spark code into Snowflake. There are few minor changes which you might need to do from a compatibility side. We are also reducing those changes to make it as compatible as possible. But essentially, your Spark code can run inside Snowflake with Snowpark, right? With the same governance and reliability of Snowflake platform. So they saw almost 350% efficiency in delivering data to their businesses. All right, let's look at the third pillar now around governance and efficiency. So when we talk about governance, there are three broad areas, right? Firstly, knowing your data. What data do we have in the system? Right? It comes back again. Firstly, knowing what data do we have in the system, right? So classifying the data, is it PII, is it non-PII, auditing, tagging, all those capabilities around data classification. So you have things like object tagging, auto classification. Recently released support for Indian identifier. So things like PAN, Aadhaar card number, GSTN, they are now available as automatic classification. So if there are columns which contain this PIIs or Indian identifiers, Snowflake will automatically classify that as a semantic category. And then you can build masking policies on top to make sure not everybody has access to that PII data, right? Very few platforms you find where you have the support for Indian identifiers. We have integrated that. Once you do that, you want to protect this with different types of attribute-based access controls, like column-level masking policies, row-level masking policies, conditional policies, and so on. So you have all of that available to protect the data. So even when you are unlocking this data by sharing to other people, you have options to control the access via these role-based controls, things like data clean room. So you only expose the amount of data required, and not the PII directly, but allowing them to only join and overlap the data where it is required. So you bring the same level of control all the way till you are unlocking the value out of that data. Now, the thing with this governance is it's available out of the box. You don't have to bring something as an add-on, or you don't have to think about it retrospectively. What is happening in the data lake world is, initially people were more worried about solving the big data problems. So we brought the engine, we brought the data, and then we started worrying about governance. How do we bring now this RBACs and ABACs into the system? And that made it very complex. So some of the people who are implementing catalogs now on the existing data lakes, they are really going through major pain points, because implementing catalog on an existing data set and platform is not as easy. You have to go through the entire definition process, integration with the environment like Active Directory, and then roll it out onto every object, every cluster, and so on. Yeah? But in here, it's available out of the box. So from the day one, you have a platform where you can start with governance baked in. And the same governance can be brought forward till the AI layer, because when we do things like embedding and vectorization, we can actually make sure there are access controls implemented at that level, so that when the chatbot is responding, it is also respecting those access controls. And finally, bringing efficiency in an automated manner with a single platform where data, AI is integrated together. You don't have to bring multiple systems into the place. And any improvements which we are making to the system is continuously flowing for you. So we recently introduced some performance enhancements on the iceberg side. Now, you do not have to do anything on your side. Those enhancements will automatically flow into the system. And without making any changes, you now have better performance and better cost efficiencies. Right? So this is continuously flowing improvements and optimizations over there. Right? Again, bunch of case studies there in terms of people who have done either time reduction, cost reduction, or faster data availability with things like Snowpark, dynamic tables, and so on. Right, so coming to the end of it, in terms of what you can do with the entire set of data engineering pipelines from data to AI, you have different constructs for the ingestion side, so integration with Kafka, different streaming pipelines, data sharing, or I talked about OpenFlow now to get data from various connectors, transforming this data through different constructs like dynamic tables, stored procedures, Snowpark, etc. And finally, delivering the data via data sharing, Streamlit for building applications, or even unloading the data to various systems. You can actually do this end-to-end data engineering framework with Snowflake. I know a lot of you like notebooks as well. So there are notebooks in Snowflake. You can work on it as if you were working on Jupyter environment in your local systems. Right? There are containers as well. So if there is something you want to do in a containerized environment, you can spin up a container and work inside there. All right, I get my ring to complete the session. This is the last one I want to leave with. Data engineering is definitely one of the most important workloads for Snowflake, but that is not the only workload. Of course, Snowflake is very well known on the analytics space, so you can do all types of analytics like embedding it, very low latency, highly interactive analytics, geospatial, time series, lakehouse analytics, all of that. On the AI side, you have embedded LLMs to do work on unstructured data like translation, sentiment detection, bringing the data to structured tables, and so on. We talked about data engineering a lot. And finally, building applications on top for delivering outcomes and collaborating on the ecosystem, not just within your organization, but taking it to external organizations as well. Right? And of course, underlying, you have the data, compute, and governance layer, which builds this platform for simplifying the data engineering pipelines. Right? So that's pretty much it from my side. Thank you so much for being here. Right?